Greetings, esteemed colleagues. This is the presentation of the report Multi-Agent Web Application Firewall Pentesting on the JADE platform by the author Natalia Maslova, Olena Lyubinenko, Yaroslav Dorogy, and Andrei Ivanov. The article considers an approach to automated data mining in pentesting using multi-agent system based on the JADE platform. The mechanism of agent interaction for vulnerability detection, the investigated, including the use of distributed architecture and machine learning to adapt attacks. Particular attention is paid to the dynamic generation of test requests bypassing web application firewall. A series of tests have been conducted to confirm the effectiveness of the approach in a real environment. The proposed system improves the performance of security analysis by performing scanning, attack, and response analysis tasks in parallel. In modern cybersecurity, penetration testing, pen testing, plays a key role in defining vulnerabilities in web applications, networks, and systems. Pen testing methods are used to assess the effectiveness of security and uncover weak points in websites, networks, and systems that could be exploited by attacks. Traditional testing method involves the use of specialized security scanners, code analyzers, which often require significant human resource and are not always capable of effectively adapting to dynamic security mechanisms such as web application firewall and IDS. Modern pentesting methods should be focused on automation, adaptability, and the use of artificial intelligence. One of the promising solutions for automating the vulnerability detection process is the use of a multi-agent system. Aspects of using a multi-agent system in cybersecurity, particularly for intrusion analysis and adaptation of defense systems, have been discussed in several works. In particular, the Article 1 analyzes attack detection method, including signature-based approach, anomaly detection, and machine learning. Some other works are shown on the slide. A detailed bibliography is provided in the end of this paper. In this slide, Article 7 is the author's attempt to implement a system using the agent script tool. but it turned out that this platform is insufficient for solving pentesting tasks. Article H uh, automated XSS vulnerability detection in a web application based on a multi-agent approach describes the development of an agent-based scanner for automated detection of XSS vulnerabilities using the SPADE platform, demonstrating its ability of bypass security mechanisms and outperform commercial tools like Drop Suite. The agent-based model provides flexibility, speed, and cost efficiency in real-world testing conditions, but lacks adaptability. Despite the existence of development, including uh, proprietary ones, previous solutions do not implement a distributed multi-agent system for pen testing that combines automatics attacks generation to bypass security, real-time dynamic pilot modification, parallel agent interaction for scanning attacks and response analysis. In the process of selecting method and tools, several platforms were considerable, such as JADE, SPADE, Medkit, JSON, and others. The most powerful tools for solving the task turned out to be JADE and SPADE, with reasons shown on the slide. However, the JADE development environment provides powerful tools for testing and monitoring agent-based systems, making it convenient for complex projects. The JADE community is larger and ensuring access to documentation, forums, and support. Also, SPADE also supports complex agent models. JADE is a more optimal choice for large distributed system due to its scalability and flexibility. Slide 7 presents the overall scheme of the proposed system, its architecture, and the interconnections between components. The main components are for agents. Recon agent, mutation agent, attack agent, cloning agent. The purpose of the agent is detailed on the next slide. Recon agent analyzes the system to determine how the web application firewall operates and filters requests. Mutation agent, based on information received from Recon agent, generates new variants of malicious requests, adapting them to detected restrictions. Attack agent send requests from mutation agent to the server, analyzing responses to check whether the web application firewall defense can be bypassed. Learning agent optimized attack strategies based on test results, adapting them to change in defense mechanisms to enhance attack effectiveness. The system operates in a way that makes the entire process a dynamic attack, continuously adapting based the web application firewall responses and applying the various evasion strategies in real time. The idea of distribution is implemented through the use of agents that operate independently but exchange results and coordinate to show a common goal. For example, the recon agent can work from different IP addresses to prevent data collection from appearing as malicious requests from a single location. Other agents such as mutation agent and attack agent can also operate on separate servers to test different attack variations simultaneously. This enables multifunctional attacks from various sources, reducing the likelihood of the entire attack system being blocked. The table presents system parameters for bypassing the web application firewall, where specific several names, address, and access point can be assigned to each agent. It also includes the names of the web application firewalls on which the system was tested. Slide 10 demonstrates the advantage of the proposed distributed multi-agent system. Scalability and minimizing the risk of blocking, improved attack speed, flexibility in adaptation and detection, protection against detection. The next step was system testing. The goal of the testing was to evaluate the effectiveness of the JADE-based against system in dynamically bypassing web application firewall using various payload mutation methods. The description of the test scenarios provided in table 3. The purpose of the first test is to detect basic XSS filters. For this purpose, The chunks encoding method hex or URL is used. It is expected that the system will not block the request and the response will be received without block. The purpose of the second test is to bypass the heuristics rules of the web application firewall. For this purpose, polymorphic SQL queries are used. The expected result is a successful insertion of SQL code without block. The task of test 3 is to analyze behavioral filters. The split bypass method is used here. An XXS attack is expected to be executed when assembling parts of the payload. The second table on the slide shows the test results examples. Test 1 was successful. URL encoding helped bypass the web application firewall. Test 2 failed. SQLi was blocked, likely due to strict server analysis. Test 3 was successful. The web application firewall failed to reconstruct the payload fragments into a single attack. The testing demonstrated that JADE against effectively modify XSS payload to bypass web application firewalls in nature analysis. SQLi requires more advanced evasion techniques. System performance monitoring was conducted on 100 test queries as shown in the figure on slide 12. The average success rate was around 60%. It's a red line. The blue line results represent the system's learning process, which gradually improved over time. Let's summary the demonstrated findings. The conducted experiments confirmed that for pentesting automation, it is preferable to use a powerful platform that enables the creation of flexible multi-agent systems, optimize task distribution among agents, and effectively adapt attacks to bypass security mechanisms. And conclusion. An approach to automated data mining in pentesting using a multi-agent system based on the JADE platform is present. The proposed architecture allows to effectively coordinate the work of agents to perform scanning tasks, generate attack queries, and analyze system responses. The mechanism of dynamic change of payload using mutation agent is considered which allows bypassing signature and herests detection of web application, firewall, and IPS. The proposed system can be integrated into comprehensive cybersecurity testing tools and improved by using machine learning methods to predict the response of different mechanisms. Thank you for attention and end.